Hi. So far we were talking about linear arrangements. Now let's talk about circular arrangements. So we go to page 11, example 21. When arranging guests around a circular table, it's reasonable to say that two arrangements are the same if only one is simply a rotation of the other. If there are 4 guests, how many different ways they can be arranged in a circular table? Okay, so let's see here. So here we have a circular arrangement. Let's say this is a circular table. We have 4 guests, A, B, C and D. They are sitting this way. So what are the same arrangements? So if A moves to this way, A, B, C, D, we will call these two arrangements as same. Another similar arrangement would be A, B, C, D. Another one is A, B, C, D. So you see that A, B, C, D, this arrangement, and if you move them one position in a circular way, in a clockwise or counterclockwise, whatever you do, they are still the same arrangements. These 4 are same arrangement. So what would be a different arrangement? A different arrangement would be something like this: A, B, C, D. This arrangement is different from all these other arrangements. So you see, this arrangement is being overcounted like 4 times. These 4 are all same arrangements. So how to count how many circular arrangements are there with 4 people or 4 elements? A simple way is, let's first treat these as linear arrangements. Okay, so let's say you have a circular table and you cut it here. You just cut it. So we say this is A, B, C, D. This is D, A, B, C. So just cut here. So this way, now these are linear arrangement. This is a linear arrangement, this is a linear arrangement, this is a linear arrangement. With 4 guests, how many linear arrangement can you get? That is 4 factorial linear arrangements. And for each case, there are 4 arrangements that are same. So there are actually 4 factorial over 4, which is 3 factorial circular arrangements. Is it clear? So if you have 4 guests and you are trying to find out how many circular arrangements can you create with 4 guests, the answer is 4 factorial over 4, which is 3 factorial. So the 3 factorial circular arrangements you can create. So let's see the related theorem here. Theorem 5. Suppose 2 arrangements in a circle are considered identical if one can be obtained from the other by rotation. Then the number of distinct arrangements of n objects in a circle is n factorial over n. Now n factorial, we know that it's n times n minus 1 factorial. So n and n cancels off. The final answer is n minus 1 factorial. Now if you remember, in case of linear arrangements, if you have n items, the answer is n factorial. For circular arrangements, the answer is n minus 1 factorial. That's the only difference. Everything else is same. So with n elements, if you are trying to find out how many distinct circular arrangements are there, the answer is n minus 1 factorial. Next is example 22. There are 6 people sitting around a circular table waiting for dinner. How many ways are there to arrange these 6 people? Part A in total. So this example is actually a circular version of the example 8 from page 3. It's the same problem, but instead of linear arrangements, it's just circular arrangements. So if you go check example 8 from page 3 and try to solve it on your own, you can just do it. So in total, there are 6 people. How many circular arrangements? So we just learned the formula. It's 6 minus 1 factorial, which is 5 factorial, which is 120. That's it. Part B. So that Alice and Bob are side by side. So we know how to do this type of problems. Treat Alice and Bob as one unit. So there are how many units left total? So there are 5 total units. The answer is 5 minus 1 factorial, and it can be Alice Bob or Bob Alice. So 2 different or 2 factorial different ways. So 2 factorial times 5 minus 1 factorial, which is 2 factorial, times 4 factorial, which is 48. So that's your final answer. C. Alice and Bob are not side by side, so we are going to do the complement method. Total number of distribution minus distribution with Alice and Bob side by side So this part is answer of A. Total distribution, answer of A. We calculated that. And this part is answer of B. So 120 minus 48, which is 72. Okay, complement method. Last one is part D. What if there are 3 men and 3 women in the group and all the women have to be seated next to each other? So let's say this is the big table and they are sitting like this. The first guy, M1, M2, M3, then W1, W2 and W3. So 3 men and 3 women, and all the women have to sit together. Okay, we solved something similar in linear arrangement part. So how to do this? This problem is also similar to C. So similar to C. Sorry, similar to B. So how to solve this? How many units are there? There is 1 unit here, big one, and then 2, 3, 4. So 4 units. So 4 total units. So 4 minus 1 factorial. times, now see the women W1, W2 and W3 and all different arrangements, but this part you have to treat as linear, not circular, because these three women are not in the whole circle. So wherever they are sitting, it sort of acts like linear arrangement. So 3 people in linear arrangement. The answer is 3 factorial. So 4 minus 1 factorial for all the 4 units, and then when you consider just the women here, that's 3 factorial. So 3 factorial times 3 factorial, which is 6 times 6, 36. That's your answer.